Okay, before we continue, one important remark I always forget to make at the beginning. When I'm talking too fast, please interrupt me and tell me, okay? Because this is my general weakness, is to always speak too fast. What I'd like to do in this second session is to talk about data handling. And indeed, I'd like to touch two topics. The one topic is data documentation. And not only data documentation, but documenting the whole research process. And the other thing is talking about organizing files and folders as well as storing files and folders, which tends to be, let's say, somehow an annoying topic for most of you, because everything tends to be clear in regard to data organization and data storage. From an archive perspective, we make different experiences almost every day. Also, well-experienced researchers come up, have no idea about the current version of the data set, have no idea about why they have lost their documentation and all this stuff. Okay, however, I'd like to start up talking about data documentation. And as I mentioned already, data documentation, it's not just a matter of documenting your data set itself. It's not just a matter of knowing what your variables contain and what the codes on the variables means. It's also due to the whole research data lifecycle. So once you start up thinking about developing a strategy to provide an answer to your research question, you should start up documenting your data already. Why did you choose this data and not other data? How did you get these data? How do you collect them? How was the sampling drawn? And so on. Why do we need data documentation? Well, this is a simple matrix of any data set, and without having additional information, you won't have any idea what the data set is about. So what we need to know is, we need to know what the study is about and by whom it was conducted, just simply to have an idea what the information contained by this data matrix is about. We have to know what the observations are. Are these individuals, are these cities, universities, states, or whatever? So on the left-hand side, we need information about the study itself and what the study contains. On the right-hand side, we also have to know what the variables are, and not only what the variable V10 means, but also what the underlying question of origin was. Was it about gender or was it about sex? And that makes a difference. And then, of course, we have to know what the codes within each variable means. Otherwise, we won't be able to understand the results of any software output later on anymore. So, simplified, documentation ensures or keeps your data understandable for yourself in the future, as well as for others that might want to reuse your data. To document your data and your research process, you can distinguish between these two levels. So on the one hand, we have the study level, and on the other hand, we have the variable level. And once again, in regard to the study level, we have to care about the aim of the study itself. Why were these data collected? And this is especially of importance for persons that want to reuse your data. They have to know the original aim of the study. They have to know about the study design. They have to know about the underlying population, how the sample was drawn, how the interviews worked, and so on. So, of course, they need information about the data processing itself, which not only includes the interviewing, but also cleaning up the data set as well as analyzing the data set. That does not mean that reusers have to be able to de-anonymize the data, but they have to know what has been done in regard to data anonymization to understand why the information is presented in the way they are presented. So this is what's going on the study level, and in addition we have the variable level. Once again, we have to ensure that we can remember what the variables mean. The label V9 is not a very good label to remember what the variable contains. So if you simply number your variables, you should have brief explanations what each of the variable refers to. And not only what the variable refers to, but also to which question in the questionnaire of origin the variable is linked. And same is true not only for the variables, but of course also for the codes and the linkage to maybe the provided answer categories in the questionnaire of origin. According to data documentation, and here I use the term metadata, which is nothing else than data about the data set itself, You can distinguish between structured and unstructured metadata. Unstructured metadata or unstructured documentation looks a bit like the desk in my office. So it's not very clean, it's not very easy to find things. Unstructured documentation is what is done in most of the research projects. It simply means that the documentation is done freely, by hand. You write down a code book, you write down a technical report about how the data were collected, and all these stuff like this, not following any kinds of standards. So this is what is meant by structured metadata. This is how Astrid's office looks like, which simply means that your documentation is based on any kind of standardized information. And you can find these standardized information on two different levels, on the variable level as well as on the study level. On the variable level, you can find coding schemes like the International Standard Classification of Occupation, so the ISCO, or the International Standard Classification of Education, the ISCAD, which simply tells you how to code the variable on the occupation of respondents or on the education of respondents. And these schemes are also there to make these codes comparable across nations. On the study level itself, we can find international standards for metadata, and the most common standard in social sciences is DDI, the Digital Documentation Initiative. So DDI is really a huge thing. They got their own data lifecycle, which looks a bit different than the one we showed you before, but indeed it contains the same steps. And currently, we have two different versions of DDI. The one is called DDI2 or DDI Codebook, which simply focuses on how to write a codebook. So DDI2 tells you exactly where to put a specific information in the codebook and how the information should look like. Beyond DDI Codebook, the more actual version of DDI is DDI3, which is Ddr Lifecycle. And this not only refers to the codebook itself, but to the whole data lifecycle. So they really care about starting up with your research idea and how to document why you need the data you have collected. And of course, it ends up with sharing and publishing the data itself. DDI, once again, it's really a great thing, especially for archives, because DDI enables archives to exchange metadata quite easily and to ensure that all necessary information is there, especially for smaller research projects. My advice would be not to use DDI. Sounds strange, but it's true, because to understand DDI and to understand why things are presented in the way they are presented takes you half a year, so it costs a lot of time and a lot of effort to follow up on DDI standards. And if you are the only one who is involved in the research project, you should fall back or rely on an unstructured metadata. It is important that the documentation is there. It is not so important how the documentation indeed looks like and that it follows up on international standards. So find a balance between focusing or following up on international standards and just simply saving time and effort to do so. We heard about DataCite and about persistent identifiers already in the introductory session, and at that moment I'd like to make a brief excursus on persistent identifiers. The reason why is because persistent identifiers sometimes present metadata schemes that might be used for documenting your data. So first of all, what is a persistent identifier? Well, a persistent identifier is a permanent and unique link to retrieval a digital object like a data set. There are different types of persistent identifiers, and what they all have in common is the fact that they are permanent and the fact that they are uniquely related to a digital object. That means if you publish a data set and you put a persistent identifier on it, and then you change the data set afterwards, add new variables, add new observations, and you'd like to publish these data set as well, it gets a new persistent identifier because it is a new digital object. The big advantage of persistent identifiers for reusers is that it almost always assigns a way how to citate the study or the digital object itself. One example for such a persistent identifier is the so-called DOI system, the Digital Object Identifier, which is controlled by the International DOI Foundation. And a DOI contains of three parts, as shown here on the right side. it always starts up with a 1, 0 dot. And this 1, 0 dot is nothing else than the identifier that the following number is a DOI. Then we have a 4-digit number. Here it is 4232, which assigns the registration agency for the DOI. So you're not able to put a DOI on your digital object on your own. You have to register it somewhere. And this is the German registration agency, which is called Ddr. And then we have the suffix at the end, which uniquely relates to your digital object, so maybe to your data set or to an image or whatever. When you know the DOI, and I think you've all seen DOIs already, because they get more and more common, especially in research papers, for citing other articles as well as for citing data sets. You might simply tap in this DOI in a DOI resolver like you can find on doi.org, or simply tap it into Google, and it will lead you directly to a landing page where you get some additional information about the digital object. What is it? Is it a data set? Is it an image? What is the title of the object? Who was the creator of origin? Where is the object stored? How is it accessible? And all these information and all this stuff. So as I mentioned already, this number here refers to Ddr, the German registration agency, and now we are back to DataCite and back to metadata. This is the metadata scheme of Ddr. This is what you might document about your data set, but it is not what you have to document about your data set, okay? So there's a lot of information collected in the Ddr scheme in the main categories, like the temporal coverage, the classification international, the version, and all these stuff. Some of these informations, but really only a handful, are mandatory if you would like to have a DOI. They will ask you for the title, they will ask you for the type of data, they will ask you who you are and these stuff, but they won't ask you about the publication date of origin. They won't ask you about the description of your data and all these stuff. So this slide is more there to give you an idea what different information you might cover by your metadata or by your data documentation. But once again, you should always remember to find a balance between documenting your data and providing information to others and the effort you invest in it. What you definitely need is you have to document everything that enables you to understand your study tomorrow and that enables others to understand your data if they would like to reuse them. And in this regard, for example, the publications relating to your data set are not of interest for a reuser. Okay? They might reuse the data without knowing what has been published using these data. But they have to know how the data were collected, for example. Okay, any questions in regards to data documentation and metadata? Because this is indeed everything.
Sorry, you were talking about DDI codebook.
Yep.
Is it some sort of consortia or alliance, or does it have any research funders among them?
I think there are no official funders for DDI. It is a consortium of different research archives from all over the world. And they meet twice a year internally just to further work on the DDI metadata standards. They call it DDI sprints. And then there are a lot of workshops and conferences referring to DDI. So for the social sciences, it's actually the most common metadata scheme. And of course, for us as an archive, we would like all archives in the world to follow up on DDI standards because it's really simple for us to exchange metadata. But unfortunately, that's not true.
So researchers going to reuse it?
In general, not. What happens in a lot of archives when you're going to archive your data is that at least some of the information is transferred into DDI standards. So Ddr, for example, follows up on a DDI standard, and DDI standards itself base up on DataCite, at least for the purpose where DataCite refers to.
The nice thing about structured metadata is, so if a researcher goes to a repository, an archive that has an upload form, then they're going to fill out some of the fields that are required. And then once we have that, we can translate these fields into the DDI fields. So that's the one advantage of structured metadata. Because if we just, then we can say a researcher enters his or her name, and this then translates into the DDI field. It's probably also going to be something like name, but this DDI field has some sort of code, and we can simply translate this, and then DDI, I don't know if you mentioned that, but it's probably also not important, but DDI is based on XML. So there is a focus on exchanging metadata, as Sebastian said, via XML between different organizations. But yeah, if you're a researcher in a project, I really wouldn't worry about DDI too much, because it's a huge complicated concept.
Do you know if there's a similar thing for life sciences or medical sciences?
I think life sciences, they also follow up on DDI, but for medical sciences, I have no idea. But in regard to these international standards, if you plan to put your data into an archive, and this is what we will tell you later on again and again, get in contact with the archive or the library as soon as possible in your research project, because they might help you to get an intention about what you should document and how things should be documented. And if you don't do so, what you should do in regard to documentation, always think about what information do I need to understand the study? What information do I need to understand the data set? And if you're not quite sure if you need the information or not, keep the information, okay? It's better to over-document your data set than to lose some information on the way. And today it might be quite easy for you to remember what you have done yesterday, but you won't remember everything in 10 years, or 5 or 10 years. And that's the important point. Or 6 months, yeah. Anything else? If not, I'd like to go ahead and talk about organizing files and folders. As I mentioned already, this might be an annoying topic for some of you if they are well experienced in doing research projects or well experienced in organizing files and folders. The interesting thing is that we have the experience in the archive again and again that well-experienced researchers come up and like to archive their data. And they send in a folder and say that this is my data set. You open the folder and it includes 10 different data sets. So you went back to the researcher and asked which is the current version. And the answer you get is, well, I don't know. It might be this one or that one or that one. But if you open them and you compare variables, whatever, you might find out by, That's not the job of an archive, okay? It's the job of the researcher to know which is the current version of the file. Organizing files and folders refers to 2 different topics. The one thing is the file itself. The other thing is talking about structuring folders and structuring folders in a meaningful way. The reason why you should do so and why you should think about this right at the beginning of your research project is because it simplifies your life. It saves time and effort. It helps others that might join your research project in a later point of time to understand where to find different files. And it also helps to protect yourself from accidentally cleaning up files and folders you'd still need. So you should think about how to structure your folders right at the beginning of a research project. You might do so hierarchically, so structuring it by topics, by the different types of data you might collect or you might have in your research project or whatever. My aim here is not to give you an advice how you should do this, because my own experience is that it heavily depends on personal preferences or individual preferences. And I think you all have ways to structure your folders. What I'd like to increase your awareness is to early think about how you will organize your folders in the research project. And then you should simply, and this is also a part of the data management plan, simply write up a brief guideline how the folders are structured and use these guidelines consistently throughout the project. We will have an exercise at the end of this session about structuring files and folders. At the end, I'll show you one example how you can do it. The second aspect in regard to organizing files and folders is thinking about file names and file versions. In regard to file names, of course, file names are of importance because they identify a certain file, and you can put a lot of information in a file name, like the type of data that is included, the name or the title of the research project, the title of the file itself, the editor's name, the version, the date of creation, and all these stuff. What you should keep in mind is the more things you include in a file name, the longer the file name becomes, and at some point you cannot see the whole file name in your browser anymore. And this is worse if the last information that is contained in the file name is the version of the data set of the file itself, and that is information you might need. So think about how file names should look like and ensure that they are not becoming too long. And the second thing you should think about is not using punctuational characteristics, so special characteristics like a hashtag, an apostrophe or something like this, and not include blanks. The reason why is quite simple. There are some software packages out there which are not able to read files including punctuational characteristics or blanks. You're able to store files including punctuational characteristics, but afterwards you're not able to open these files anymore. So you've lost your data not because they were deleted, but you destroyed your file simply by storing it using a wrong characteristic. So once again, think about how to name your files, develop a clear strategy, a consistent strategy, and use it within the project. Same is true for versioning. You should always version your files just simply to ensure that you work with the current version of your file and not with a version which is obsolete already. This is of special importance when you work in research projects, in collaborative research projects, so you have to share files with others and you have to ensure that everyone works with the current version of the file. You might do so by different strategies. You might simply include the version as a part of the file name. Once again, remember, the file name should not be too long, not include punctuational characteristics and blanks. Same is true for the version, of course. You might include the version in the header of the file or in the headline of the file itself, which of course means that you always have to open the file to see the version. And last but not least, you might write down a separate log file for the versioning. This can be done, for example, in the data management plan, or at least you should have a reference in your data management plan that links back to the log file for versioning and tells you the log file for versioning is stored here and there, and it's called like this. And of course, you might combine all these different strategies. Okay, indeed, that's all I'd like to say in regard to organizing folders and files. There is one final slide I'd like to show you. And once again, you will get these slides at the end of the workshop, so I won't go into detail here. I'd simply like to increase your awareness for two important things in regard to file formats. The first thing is, when you work in collaborative projects, you have to ensure that everyone in the project is able to use the file formats you've chosen. It doesn't make sense to work with SPSS if all your partners in the project use data. And that is what you should think about early in your research project, okay? So if you work in a collaborative project, decide on the file formats you're going to use and then use them consistently in the project. And the second advice is due to sharing the data with others, especially due to archiving the data. If you plan to archive your data, you should get in contact with the archives quite early and ask the archives what file formats they recommend. It saves a lot of time for you as well as for the archive. And transforming or transferring file formats is always risky in regard to losing information. Okay, an easy example is in a software package like SPSS or Stata, you can label files and codes directly. If you transfer the data set into an ASCII code in a TXT file, all these labels get lost and the documentation has to be stored somewhere else. So this example shown here is from UKDA and the file formats they recommend for different types of data. Any questions?
And maybe one more comment about the file formats. It would be part of, as Sebastian said, it's part of data management planning to think about which file formats do I want to use and what are the implications of that. And sometimes, I'm probably going to talk more about this in the archiving session, but you have to think about, if I want to share the data, who's the target audience for my data, and which file format is this target community most likely going to be able to use. So if you plan on sharing the data, it would be a good idea, as Sebastian said, to discuss with the archive or a repository what a good file format is. But of course, there are also scenarios where you have a project where you think, okay, the data is, for example, very sensitive and I won't be able to share it with a wide audience. Or you are in a project that has a very specific research design and you need a very specific software to achieve what you want to achieve. In that case, there may be a trade-off between using a specified software that is very specific to your demands to achieve your research output. So there may be a trade-off between that and using a file format that is widely accessible to a very broad community. And the best thing is really to strike a balance between these two things. So there is no point in using a software that does not fulfill your needs just because more people will be able to use the output in the end. So you really have to think about what is it that I really need from a software, and then also think about the implication that might have for sharing. So it's really something where it's a good idea to think about what you are going to do with the data at the end of the project at a very early stage.
Any further questions? Otherwise, I'd like to go ahead and talk about data storage and data security. And once again, this is a matter of the whole data lifecycle. It might be that you think about, I care about my data storage already, and there is no need to think about it. Well, there are really worse examples out there telling a different story. And I just want to talk about one example. There was the University of Southampton, where the Biological Institute burned down in 2006. They had a great backup strategy. And their backups were stored on a different server, but in the same basement as the server of origin. The firefighters came with all the water, and both servers were destroyed. So the backups were destroyed as well. They had backups, they had a great backup strategy, but no one thought about that. If the servers are destroyed, they are both in the same building, they might both be destroyed together. And this is what happened. And a lot of researchers lost their data at that moment. So, talking about data storage and data security, we first of all have to think about backups and what backing up means. So, what you should keep in mind is that, of course, digital media are failable. So your computer might work fine today, but tomorrow it's just simply broken. And if your backups are stored on your computer, it means that your backups are not accessible anymore. A backup is simply, or is nothing else than an additional copy of your working files that allows you to restore your working files once you lose them. But to back up your files, what you need is some kind of a backup strategy. And once again, this is something, or this is a part of your research data management plan. So it's just simply to define how your backup strategy looks like. And I'd just like to give you an intention, what is of importance in regard to a backup strategy. What you have to care about, first of all, is what is backuped. And the question here is if you really have to back up everything all the time, or if it's okay to back up just something. And if you back up just something, what is this something? Finally, you might only back up changes, and then you have to decide on when the change is big enough to back up the whole file. So once again, it's not that I'd like to give you an advice here to always back up everything or just back up the most important files. You have to define a strategy on your own, and you have to find out what has to be backupped. The second question is, where are things backupped? Is it done externally, locally, or on remote copies? Once again, remember that backing up on your own computer doesn't make any sense if your computer fails, because it means that your backup is not accessible anymore. So you should back up at least one of the copies externally. And the best thing you can do is not to back up these, or to have this external copy not at the same place where your computer is. So if your office burns down and your external copy is at home, you will hopefully still have this external copy. Third thing to think about is how often are things backupped. And here I'd like to give you an advice. You should at least back up in triplicates. So have at least 2 additional copies where one of these copies is stored externally. Then you have to think about how long are things backupped. In a research project, you produce a lot of files, a lot of working files which are obsolete tomorrow already, because you have a newer version. And then, of course, you have to decide how long do I have to keep these old versions. One big advice, never delete your original data set, okay? Always keep it, and always keep it backed up safely. But for temporary files, you might, of course, delete them in between, which also means delete the backups, just simply to save some capacity on your computer. And last but not least, think about the responsibilities of backing up. This is of special importance, once again, in research projects, in collaborative research projects. Don't believe in that your partner will do the backups, and your partner believes in you will do the backups, and at the end there are no backups. The best thing you can do, and this is true for most of the institutes nowadays, is to have an automated backup process. That means if you store your data on a specific server, this server is backupped frequently, and in general not only once but twice. But what you need at that moment, of course, you need to know whom to contact once you lose your original files. And you should also ensure that it is backupped more than once. So if your institute has a backup strategy, and I guess it has, just find out how this backup strategy works. And just simply write a short remark down in your data management plan. It doesn't cost very much. The last thing to keep in mind in regard to backups is that you have to verify your backup, okay? Just backing up your stuff and then recognizing that your backups are damaged once you need it is worse. So what you should do is you should recover your backups, and you should check that your backups really work. And finally, what you have to do in regard to your backups, or what you should do in regard to your backups, you should treat them the same way as you treat your original files. We will come back to this in a moment when we talk about data protection. If you're going to protect your files because they include sensitive information, and you do this by a password or encryption, you of course have to encrypt your backups as well. Because not protecting your backups, it doesn't make sense to protect your working files. I don't need to access your working files if I can simply access your backups. This is something you should keep in mind. Okay, and we're up to data protection. In regard to data protection, we have to protect at least some file by legal requirements according to an unauthorized access, use, change, disclosure, or destruction. For some files, this is legally required, but I think for all of your working files in a research project, this is an individual interest you should have to protect your files from unauthorized access. Once again, you should take care about legal requirements in this regard. According to your national data protection law, you might have here in Estonia, or you have here in Estonia, I know. But also in regard to the EU protection law, we are all living in the EU, which has an advantage, at least for a workshop like this, because there are common requirements in regard to data management and data protection. And in regard to data protection, the important EU directive is the Directive 1995/46. This directive is currently being replaced. So currently it is in the triangle between the European Parliament, the Council, and the Commission. And they promised to have it out this year, so now they promise to have it out next year, and hopefully we will have it sometime in the future. However, one requirement of this directive is that personal data, like contact information, have to be protected. And that means, first of all, you have to separate them from your research data. In your research data, you do not need contact information. Sometimes you might need them, and there are exceptions, if you really want to know where people live in your analysis. But that means that you have to specially protect your whole research data set. In general, you won't need the contact information. Separate it from your research data set, protect it, and protect it. One important thing to remark in this context is that according to the EU directive, personal information about EU citizens have to be stored within the EU. So Dropbox is no place to store contact information because the server is in the USA, outside of the EU. Okay? We have a lot of participants in workshops like this that come up and say, oh, I'm not allowed to store my contact information on Dropbox. Wow. So just keep your data protection law on the national level as well as on the European level in mind and follow up on the requirements. How you can protect personal information? Well, there are two major strategies that should be combined. The one thing is to have a strong password on your computer as well as on your folders. And second, to encrypt at least folders that include or files that include sensitive information or personal information like contact information. So give me a moment to talk about passwords. The password 1234 is used more often than you might expect, but it is definitely not a safe password. A good password has at least 8 characteristics. It should be up to 15 characteristics or even more. And it should be a random combination of characteristics. So I am the best is also no good password. What you should do is you should combine upper and lowercase letters. You should include numerals as well as punctuational characteristics. And if you do this randomly, you will get a quite strong password, at least if it's 8 to 15 characters long or even longer. There are two important things to keep in mind in regard to passwords. The one thing is you have to remember the password on your own, because if you can't do so, it's worse. And the second thing is to write your password down on a post-it and put it on your desk is no solution to remember the password. In addition, sorry.
Yeah,
No.
I was just wondering your take on passphrases.
Sorry, once again.
Well, like there's some suggest because those passwords are unrealistic to keep in mind often. And what people suggest is to use passphrases like sentences.
Yep.
Which makes sense to you, which are easy to remember, but
You might do so, and the advice I'd like to give you is to replace some of the letters in the sentence by numbers, like an E becomes a 3, an L becomes a 1 or something like this, and to replace some of the letters by special characteristics. But just remember that the L becomes an apostrophe or something like, yeah.
Yeah, but basically, the longer the password, the more difficult it becomes to break. So that's one of the advantages you have with sentences. And yeah, as long as you have a sentence and still, I mean, with the sentence you automatically have upper and lowercase. So if you manage to squeeze in a few numbers, for example, or like Sebastian said, a special character even, then that's a pretty good password. And sentences are easier to remember. I mean, there are also things like keypads, for example. So there's software that manages passwords for you. So you have one master password, and then there's an encrypted database with your passwords. And this program, for example, also generates strong passwords for you. But I use it, but I'm still sometimes, yeah, I'm skeptical because the passwords are stored on my computer. But as it's encrypted, and if you have a strong password to protect the passwords, I mean that might also be a way to make sure that you can always access your passwords. Because of course we also recommend not to use the same password for all of your logins, because if you do that and someone does get access to your password, they automatically get access to a lot of the services that you use. So the recommendation is also to have different passwords, which makes it very fun to remember them all.
Okay. Then finally, in addition to having a strong password, you should also encrypt your files, at least if they contain sensitive information like contact information. So encryption is nothing else than an application that uses an algorithm and that replaces the meaningful distribution of characteristics into a random distribution of characteristics. And if someone accesses the file, the distribution of characteristics doesn't make any sense. What you need is a key, or better to say a password, so you have to remember an additional password, that allows you to decrypt the file once again. The easiest example for encryption, or an easy example for encryption, and there are a lot of software applications available for free, is 7-zip, which is part of the zip function of your computer. And when you're going to zip a folder or a file and go to add to the archive, it automatically asks you if you'd like to zip these, to encrypt the file while zipping it. And then, of course, you have to enter a password, and this password is the key to decrypt the file when it is unzipped again. The advantage is also if someone is able to hack your computer due to knowing your password, and of course you use different passwords for your computer and your encryption, the person won't still be able to use your files if they are encrypted. And once again, you should do this at least for files and folders containing sensitive information. Any questions in this regard? Because otherwise we are almost back in time. What I'd like you, oh, sorry, this is first of all a list of further readings. What I'd like you to do now is to split you up in 3 groups, and each of these groups should follow on one of the topics I'm going to show you on the next slide. This is due to the sections 2 and 3 of your data management plan template. And what we want you to do is briefly discuss each group a different topic of what I'm going to show you next for the next 25 to 30 minutes, and afterwards we want to have one of each group to briefly present the results of the discussion and just simply tell us what the group came up with. So what we like each group to do is, first of all, one group to focus on documentation and think about what documentation do you need in your research project to ensure the understandability of your data, and how will you capture this information. In the second group, we would like to focus on the backups and data storage and develop an initial strategy for backing up. And likewise, a third group should focus on managing folders and files and develop a basic strategy on how to structure folders as well as how to name and to version files. Last but not least, before I'm asking you to split up in these groups, there are a lot of librarians in here for which these exercises might not be so interesting. If these people would like to discuss or additionally discuss things in regard to data documentation and data storage, Astrid would welcome you to join your discussion and answer questions.
Yeah. And depending on how big the groups are getting, we could also split up into more than 3 groups, so that 2 groups have the same topic, so that would also be possible, because I think we may probably be a bit too many for into. Can we just maybe check briefly who would be interested in which group, so we see how many people?
So who would like to focus on documentation? No one. 1, 2, 3. Data storage and backup. And the managing of folders or organizing folders and files. 1, 2, 3. It tends to be perfect. So all you have to do is to find a table where you can sit together as a group. Okay, would anyone of this group for documentation be willing to briefly present the discussion and maybe what you come up with at the end? This one. So we can at least record.
Sorry, I had a question about the metadata standards, because I have no idea what kind of standards there are, and we were discussing about this, and I had nice colleagues who, who were so nice and explained so many different standards. Annika is from
Estonian statistics, and we try to implement different standards, but it's quite difficult because there are a lot of materials and specific terminology to understand the standards and models to integrate them to our in our system. But yeah, it's all.
So did you have examples of standards that you thought could be useful, or?
No, for example, the DDI to implement for the metadata, to manage the data.
So I have a question. Are you speaking about public data or research data?
Both public data and also research data.
But what we also discussed is that someone has to prepare the metadata standard for researchers, because they have no idea about any standards, I think, concerning with metadata. And I think it's a waste of time if they should search for standards. So, and I think our colleagues from libraries are dealing with that.
Anything else? I'll take this with me. Okay, I think as you mentioned already, it's hard to develop standards, and DDI, it's not that they were sitting 2 or 3 people together discussing that, let's set up a standard for metadata. Okay, it's a really long-term alliance, and they really work hard on how to implement metadata standards for the social sciences. And once again, what you should keep in mind is DDI is very interesting for archives and libraries and repositories maybe, but for a single research project, it's really hard to follow up on this. What I have here is a brief wrap-up of the part of documentation, just simply to remember you what you should think about when you're going to document your study or your data set for reuse. So once again, distinguish between these 2 levels and think about on the study level all the information that is needed to ensure that your data are understandable for someone who's like to reuse your data. So think about the aim of the study, who you are, by whom you're funded, the population you sampled, the underlying population overall, the method of data collection, data cleaning, and anonymization. And you might do so, of course, using metadata standards like DDI, which exactly tells you what kind of information is needed and where this information should be put. But if you're not familiar with DDI, you might simply do so writing down a technical or methodological report that contains all this information in what is called an unstructured way. But indeed, it's not the problem if it's structured or unstructured. The problem is if the information is there or not, and you really need this information to reuse the data and to understand the data. This is of special importance to to know about the quality of the data, if you want to reuse data, the first thing you in general do is you check for the study level description and what the study is about. And this gives you a first intention about the quality of the data. Of course, it's not all about quality, but it gives you a lot of intention. And then, of course, on the variable level, you might simply keep all the documents used in the field, so the questionnaire of origin, which already contains the questions and provided answer categories, the interviewer instructions, the show cards handed over to participants, and all these stuff. And of course, you might write it down in a codebook, including also the variable labels, as well as the means of the labels, and the codes. And in addition to simply including variables, or the names of the variables and the codes, you can also include, or you should include, variable nodes, which, for example, explain how variables were constructed. So if you generate a variable out of different questions, a codebook is a nice place to explain how it is done. Which categories from which question were used to generate a specific variable. Okay, and in general, this is done in a codebook, which is also mainly freely written and not following up on standards. But once again, DDI also provides a standard to write a codebook and to provide the information at the right place in the right format. Any other questions in regard to data documentation? If not, where's the group with the backup strategy?
Hi. We had a very interesting and heated discussion on various data backup strategies. And I guess a takeaway is that people are sort of aware what should be done, but everyone puts together their own picture. And people are not aware of all the regulations. And so the default approaches, such as, I don't know, using Gmail or using Dropbox, for instance, they pose certain security risks. So I guess what could be useful would be a very certain guidelines of what to avoid and what to do instead. And then also, when students are handed projects, we agreed that actually the department or their supervisor is responsible, the students are aware of the correct data practices, and at least the students should be informed of how to deal with things. And yes, well, the data backup should be at least in 3 places, and depending on the stage. So for instance, if we do a paperback questionnaire, then this paperback questionnaire should be digitalized as quickly as possible with all the data, so you get at least first backups. And when this data has personal info, then this data is particularly sensitive, and that should be stored on a secure server. But once you anonymize it, then it's slightly more widely shareable. And this is what you also share in the public repository, or for your own personal use later, or hand out to students. And then finally, when you analyze data, it makes sense to do regular backups again by your own personal means, but I guess also to the institute server, so they have idea what you did, and also that the result, if it gets written up, you would get in the pub backed up somewhere, for instance in DSpace. And also it would be nice to have both the anonymized raw data and also the analyzed versions of the data available in a public data repository, if the data allows that, of course. Anything else did I miss? So it's difficult, but doable, I guess. And structured instructions would be nice.
Okay, I think there is no need to talk about all these things because it has been on slides before already. What you should keep in mind are two things. First of all, you have to develop some kind of backup strategy. And in general, your institute has a backup strategy already, which simplifies your life if you know how this strategy works, okay? So just to give you an example of GESIS, our home institute, there are several servers which are backed up, but not all. So what we have to keep in mind is where to store things, and then they are automatically backed in triplicates and backed externally. We know about this, and we also know about with whom to get in contact once we lose the files. And this is what you should check. And if such a backup strategy exists in your institute, well, that's the best thing that could happen because it simplifies your life. A second thing I'd like to say, because you mentioned Dropbox and Gmail and also Google Docs, excellent tools, and they all provide backups because they store everything forever. The tricky thing is that you should carefully read through the conditions of use. Because the conditions of use of Dropbox and Google Docs say that everything you do there becomes an intellectual property of Dropbox or Google Docs. Not exclusively, but they have the right to use your materials. And that means if you store contact information, they have the right to use these contact informations. And once again, you are not allowed to share contact information with others. You have to ensure that your participants are protected and their identity cannot be, is not available to others. So Google Docs and Dropbox is definitely no good solution for backing up sensitive information. It might be a nice solution, for example, for your data management plan to use Google Docs. How should Google Docs use your data management plan? And even if they do so, well, what shells? But for sensitive information and sensitive files, don't use it.
I just realized that people often use Google Docs for registering people for conferences. But then, by definition, is contact information in the...
Yeah, it is. Anything else? If not, I think you were the last group.
That's a lot of
Our session or our work group, our question was quite complicated because we spoke about data gathered from archives abroad, and now they have their systems there, and it is very unique and very important. And then we need, in our purposes, this information and our systems and how to organize the material. Huge amount of material, for example, 17,000 pages, and from 90 years. And it means that we need some kind of algorithm or some kind of structural folder systems. And it is our question is for you, of course, how to organize such a kind of materials where you need, for example, topics, subtopics, decades from 100 years. But these materials are in archive are very well organized. It is surprisingly how they established a system which can exist and work until nowadays. And they started in 1920. And now, in this sense, for the future, we need that this system and our information, for example, next researchers can go and elaborate there more material as well. And the second level is how to organize this material for our researchers. Question for you.
I don't have a one-size-fits-all answer, I'm afraid. I mean, it really, I mean, how you organize material just really depends on the type of material it is. And I mean, there are different ways of doing that. I mean, you described it's material from many different centuries, or yeah, at least decades. The question is, what is the easiest way of organization so that users can find what they're looking for? And I mean, I don't have an answer for that because I don't know the material, but that's something to consider. If I look at our archive, the GESIS data archive, so we have, I forgot to actually mention that in the introduction, but we have empirical social science data, quantitative studies, and we also work, basically we work with a file system. So all of our data is in a file system, as you would know from a Windows computer, for example. So I mean, on top of that, we have a layer that helps people to access this data. So we have metadata that allows you to search in the system. But on the bottom layer, what we have is we have folders with one unique number that identifies the survey that is in this folder. We call it the study number. It's a bit like it's like a DOI, only it's not a DOI, but it's only valid within the archive. And yeah, so we decided that for us the best way to organize our material is by study. So each study has one folder, and then in each of these folders, again, we have subfolders that are similar, are the same across all of the studies. So there's one folder that contains the files as they were originally submitted by the researcher. Then we have one folder where the versions that go into the access layer are. But yeah, so that's the way that we do it. But there are many different ways of doing it. So the question is also for the material that you described: is there a catalog where we can search for this material? So if there is, then maybe the more relevant question is not how the file system is structured, but what kind of metadata you use to describe the material, because then a researcher doesn't have to go into the file system and find things, but they go to the catalog and then they search for material. So that's I don't know, does that help as an answer?
In this sense, if you need two or couple systems, how to organize a double or 3 levels a catalog system, because you must get the information from the previous archive where they are, then our copies as system, and 3rd level as different studies and purposes.
Yeah. I mean, it's a very individual. It's hard to say something about this without knowing.
Some examples, for example.
I find it difficult. Because I'm not quite sure I understand how the different sources that you describe come together.
For example, it is a DPC archive. And that is their organization. And of course it is for them, and if you are covering material from this, it means that next must get the same information and more he or she wants from this original archive, and how to develop parallel systems.
I think it's always a problem to develop parallel systems. I mean, the question is, can you use the metadata from the one place and then direct? I mean, you can duplicate the metadata and have parallel access points for the metadata, but it would be a good thing if the material is in one place, so you don't have different versions for that. So that's, I think metadata is maybe a way of solving that.
I think this is how we mainly do it in the archive. It's a matter of the metadata we have and how we describe the studies. Because indeed what we do is we only have a 4-digit number for each of the studies, starting up with a CA, which is the old name of our archive. And this number uniquely relates to a specific study. And then within this study, we have different folders saying that this is about the documentation for this study, this is about the data, and so on. And then we simply have a versioning to know which is the current version, or which refers to one version of a data set, which is also DDR standard. It's a 3-digit version, so we have this 1 dot and then 2 additional numbers. 1 simply assigns that this is the original study. A 0 means that there have been no smaller changes, and an additional 0 in the suffix means that there have been no changes at all. So what we can do is we can follow up according to the documentation, which refers to which version, and which is the current version, which simply means it has the highest number at the end. And the problem is less how to find this in our system, because, as Astrid mentioned already, it's all about the metadata. The metadata clearly describe the study, and once you know the metadata and once you know what you're searching for, it points you directly to the study you're looking for.
As I understood the problem was that you didn't have a data management plan before you went to the archive. So that was a problem.
That's true.
But how to solve a problem if you didn't have this data management plan, and how to later organize the materials so that anyways, that's what
I think for
it's probably a topic for a whole new workshop.
Yeah.
And we have
exactly.
also workshops on, I mean, this goes more in the direction of how archives work, how digital preservation works, because it's at that point it's probably less the problem of the researcher. It becomes someone's vibrating. It becomes the problem of the archive or the library, and yeah. So this is something for an entire workshop to discuss how to best organize. It's difficult to answer this briefly now, but we can. I mean, we're not out of the world, so it's definitely something we could discuss.
And let's add up, I think for an archive, data management plans are nice for acquiring the information and for putting the information into the archive. Within the archive itself, a data management plan is not helpful anymore, because we're talking about thousands of different studies, each of them having different versions, so we are talking about a few dozen thousand of different files that are there. And they, of course, have to be organized differently than in a research project where we're talking about a few hundred files. What I'd like to show you, maybe this gives you an answer already, is just the wrap-up on organizing folders and files. So this is just one example how you might structure your folders in a research project, referring to different topics. So we have a folder on organizational, we have a folder on literature, on design, on the data itself, on papers written, and which is unfortunately always there is a leftover folder for others, for stuff where you don't know where to put it. And then within these folders, you have subfolders, for example, referring to primary data and secondary data, and within the primary data subfolder, we have subfolders referring to data documentation, to syntax, to the output of the raw data to check the quality, and so on. So this is just an idea how you might structure the folders in a project. Indeed, in a research project, if you structure your folders by topics, you will almost always come up with a structure like this, because it's always the same types of topics you have. You have the data, you have the papers and proposals you write, you have the literature you use, you have information about the design of the study, and then you end up with a structure that looks quite similar to this one here. But once again, it's just an example, it's not how things should look like. In regard to managing file names and versions, These are just two examples, and as I mentioned earlier in this session, it simply depends on your individual preferences how you're going to do things. The idea here is just simply to start the file name with the type of data stored in this file. So it might be a paper, it might be a data set, it might be a proposal or whatever. Then an underdash, the name of the file itself, and it depends on how you title your file, and an underdash with the version in it. And for the version, I simply use the example of including the date of creation of origin as well as the acronyms of the creator. So, for example, we might have a file that is named data, so it's a data set, underdash RDM data, because this project was called RDM, underdash, and then simply the date when the file was created of origin and the acronym of the editor, so SN for my own name. But once again, it's just an example, and you might put into a file name whatever you'd like to do, and your versions might look like however you prefer. It should be consistent. That's the important thing.
Just a comment. If the chart or organizational structure on the right side, it looks more like a project management plan, not research data management plan.
Yeah, of course. This is not about the research data management plan. This is about how you should organize your project. And in your research data management plan, you should just notice that you care about the structure, about your folder structure and how your folders are structured. This is really to organize your project, and it's not to do your data management. It is a part of data management in that sense that you should define an early strategy and that you should use this strategy. And a simple way to include it to include this, or the question how to organize folders and files in your data management plan is making a screenshot of your folders. Anything else? If not, we are almost back in time, so we have lunch break now, and we will continue at 1:30.